question is, what is the cost of an IMS beacon?
Regarding the cost of the IMS transmitters, so our idea is to minimize as low as possible. So that's one of the reasons that we would like to have LSI chips. So at the moment, the device we sold, the IMS module, so it will be a few tens of dollars. So you can assume around $30 or like that. But it will, our target is probably it will never exceed more than that. That's for the module.
Yes, Philip?
I have a question for Chris. In the two case studies that you presented, you mentioned that there was no site survey, so based on the locations you were able to get position. Were those based on propagation models? Like what kind of algorithms did you use there to get position?
Well, without digging too deep into that, it was based on propagation modeling and using the geometry of the access points themselves. So basically allowing the client algorithm to figure out the appropriate propagation model for any given point and correct any irregularities at positioning time.
Farshid?
I have a question regarding IMS. Do we know the impact of IMS on regular GPS in terms of changing the noise flow?
Sorry, I could not get the question well.
My question is, in a regular mobile phone form factor, GPS receiver might not be ideal, and your filter might be slightly wider, and it might actually have some residual impact from the IMS as part of the noise. It might actually increase the noise floor. I was wondering if you guys did any test or any measurement on impact of IMS on regular GPS performance in indoor.
Yes. I think your question is related with interference and all these issues. And we did lot of tests and experiments and also the simulations to find out how much interference you might have from IMS. And in the guideline, which is also published in the QGSS IS document, you can see in the annex. And there is a guideline that the power you can transmit to avoid the interference to the GPS signal or the signal level you can transmit. And based upon the area, for example, if you are near the border between outdoor and indoor, like in the entrance, so your GPS signal is still a little bit stronger. So you can have a IMS signal level transmitted at a little bit higher level. And if you go inside the room, your GPS signal is much weaker. Like in this room, the signal is much weaker. And if you want to avoid weak signal GPS receiver, then you also transmit IMS at a little bit weaker level. So that means the guideline is that at the receiver antenna, you should not exceed the maximum power, which is mentioned, for example, minus 120 dBm or minus 130 dBm. So based on that, we need to calculate how much my EIRP power should be at a transmitter. And we have a tool to do that, the simulation tool, and based upon that, we fix the EIRP power. And that normally to cover a 10-meter area, so the guideline is around minus 76 or 70, around minus 76 dBm shall be good enough, and it will not have any impact on your GPS receiver. That we tested. So we tested, we did experiments, we transmit the signal in the indoor, so a lot of experiment data we have.
And how much help do you get from this 2 kilohertz offset of the central frequency, of the middle frequency?
How much the cross? gain.
offset
Okay.
of
So when we do,
IMES.
yes, when we do the 8.2 kilohertz offset, so I showed in the graph that, and this is basically to avoid because we need to minimize the interference to the weak signal receiver, because now the weak signal receivers are coming up, they are going down up to minus 158 dBm. So if you are going minus 158 dBm in the acquisition level, then we cannot have more than 24 dBm strongest signal from the IMES. So we need to limit the IMES power to that level. So that is one guideline that you can transmit a level. And with the 8.2 kilohertz offset, based upon your integration time, coherent integration or non-coherent integration time, so we can see from that chart how much cross correlation we can have it. And that is limited, that is within the 24 dBm, 22 to 24 dBm.
Yeah, I'll ask a question. See, in this morning session, we heard Cormac and Frank and Ted say that accuracy of single-digit, low single-digit meters would be about right. So, question for all three panelists. It appears that that's achievable. The results that Chris showed us, a handful of meters without any participation from the service provider. So the question now is, what happens? Is there any value to decimeter level positioning? Is there any value to centimeter level positioning in indoor market? The GPS can give you a range of accuracies depending upon what you bring to the table. And of course, the receivers that give you centimeter level positioning cost a lot more than a receiver that is built inside a smartphone. And I say that because the first GPS receiver I bought for my lab cost $160,000. And see today, and then Frank told me just a few years ago that now the cost to manufacturer of cell phone now is down to fewer than fingers on one hand, maybe divided by two, rounded off. But in any case, the cost certainly has fallen a lot. The question is, so is there even any value to decimeter level positioning, centimeter level positioning? Is it reachable with the current technologies? Do you see a way of the technologies of today going to that level with just more calculations, more processing? Lionel?
Okay, I would say number one that the GPS accuracy is really valuable where you have no visual reference around you. So that really makes sense, yeah. So now indoors, I would say that if you are in, let's say, a 3-meter vicinity of what you are looking for, probably you can fill in the blank yourself and figure out what you are looking for. So it's not obvious for me that the typical user scenario will benefit from the very high accuracy. But now if we are talking about, let's say, maybe machine to machine, I don't know what kind of machine could it be. But, okay, maybe we can think about, I don't know, maybe automatic warehousing system. So that would make sense if you want to position, let's say, a grabbing device to pick up an item or something like that. So, but for the general market, I think that probably the 3 to 5 meter level is quite sufficient for a majority of applications here. I would say maybe the key point is to have an accuracy such as that you are not making any mistake on the aisle. You don't want to be on the wrong aisle. Beyond that, it's not obvious for me that the use cases are clearly defined yet.
Dinesh?
Yep. Considering the IAMS application or the IAMS technology, what I would like to say is that we don't focus on the accuracy of a few tens of centimeters or like that. But what is more important is that the system should be able to tell you where you are, like whether you are in this room or the next room. That should be very clearly understandable. There must be very clear separation between the two locations. Like if I'm here in this room, when I use my device, it must tell me that, okay, you are in the workshop at the moment. It should not tell me that, it should not just give me that the information that I'm in this hotel. I would like to know where I am at that time. And that's what IAMS will provide you. And regarding the accuracy, or like for hospital, so we have different levels of accuracy defined. For example, to monitor a patient on the bed, whether the patient is on the bed or not, we transmit very low power to cover just the 1 meter cell. Okay. So we can do that. But to have another, like in this type of environment, we need to transmit a little bit more power to have about 5 or 10 meters radius. So just so within few meters of accuracy, I think should be enough. But as if we consider for the machine or machine to machine or interface or robotic applications, they may have a different requirements, maybe few centimeters or tens of centimeters they may need it. But as far as I'm considered, this is basically for the people for all these location-based services, and I don't think decimeters, centimeters accuracy would be necessary for that.
Okay. Chris?
Well, I think for the sake of argument, if we were to assume that such technology existed today and we said we could offer tens of centimeters accuracy, I'm sure that applications would find ways to use that. That seems to be what's happened in a number of areas. In terms of the technical feasibility, I think we also know how to do that. I was disappointed to see that our Nokia speaker didn't make it, because I remember at the last one of these symposia, they talked about using dedicated Bluetooth beacons to provide accuracy on the order of a few centimeters. So that's also doable. However, the technical hurdle and the business hurdle seems to be that you're going to have to spend money for the additional hardware. So at some point there will be a limit to what we can do with algorithms alone. So there will just be a trade-off between the cost of the additional equipment and the need for additional precision.
Any other questions? Now
the ARMS technology on the client side, on the mobile device, as long as you have GPS, you don't have to do anything else. And that's one question. And the other question is as regarding interference. Have you tried to have somebody else, an independent party, to decide whether there is going to be independent interference or not? Because if you look at what happened to Light Square in the US, so that they felt that they have the technology, there was a lot of momentum, and at the end, it ran into problems.
Okay, let me address the first question. If you have a GPS receiver in your mobile phone, so what you need to do is just you need to modify your firmware. That is, you need to implement the PIN ports on your receiver, and you need to modify your navigation decoding algorithm to get to read the position data as is specified in the QGIS document. So that's, I think, that's the software upgrade in the system. So as far as the interference issue is concerned, so your question is whether the third party or the independent party has evaluated or whether they have did some very critical review on that. So at the moment we are doing ourselves, and also we have the consortium, and many members of the consortiums, they are doing their own test. They are evaluating themselves. So outside of Japan, so if you are interested, we can provide our system and you can do it. And last year in the GNSS symposium in Japan, we have international guests, and we did some demonstrations for them. We transmitted IM signal inside the laboratory in the tour where we have an exhibition, the university exhibition hall, and in the exhibition hall you have different pieces where when you go near there, you get the information of those exhibit items. And there are people from the US and Europe and other countries, and they came with their own GPS receiver, and they measure outside when we don't transmit IM signal. And okay, then we said, okay, now we'll transmit IM signal. So you measure first outside the building. And we did the same inside the building. So they measure the GPS signal inside the building with their receiver when there's no IMs, and then they measure when the IM signal is transmitted. But this is just a sort of a simple test. It's not such a critical or such a test. But they were quite, I think, satisfied with those results. But as you said, yes, we still need maybe more third parties investigation on that, and we are sure that there will be no problem at all. And one thing you have to remember is that IMS is for indoor area and deep indoor area. It's not for outside. It's not for just the open area. So where you don't get the GPS signal, you use the IMS. So that's the basic concept.
Okay, we'll continue the discussion, but we'll conclude this session. Thank you all.